This, we want to determine the speed of the airplane at 4 seconds and at 5 seconds. So write your answer in the box next to each airplane. So after we've calculated and we see that 3 seconds is figured this way, it's 8 meters per second squared. The acceleration is constant, so we can add the 24, which we got from the 3 right here, meters per second. And if it is increasing 8 meters per second, that will be 32 meters per second. We do the same for this box. So now, after 1 second, it is actually going 32 meters per second. And we add another 8 meters per second. And that total at 5 seconds is 40 meters per second. So, large accelerations are part of the thrill in many amusement park rides. The problem below are based on the actual amusement park rides. So let's calculate something here a minute. One type of ride falls straight down for 3 seconds. During this time, the ride accelerates from a speed of 0 to a speed of 30 meters per second. What is the average acceleration of the ride? Well, to figure out, we say, what's the initial speed? I'll look at the problem again and say, when did it start? Well, it started at 0. So that is our initial speed. And then we look for our final speed. It's going 30 meters per second when it gets to the bottom of the hill. And do we know the time? Yep, we know the time. That's 3 seconds. So here are all our knowns. Now to calculate our average, we're going to use this formula: final speed minus initial speed divided by time. So it's final speed, subtract initial speed and divide all of that by time. So it should look like this: final speed minus initial speed divided by time. Once we have that set up, then we can put the numbers in. So what was the final speed? That was 30 meters per second. And we want to subtract the initial speed. Well, it started at 0. And then take that and divide it by 3 seconds. Well, if we have 30 minus 0, that's going to be 30. And that is divided by 3. Working that out in our heads, 3 goes into 30 10 times. So then the answer is 10 meters per second squared. Next, we want to calculate a roller coaster accelerates from a speed of 4 meters per second to 22 meters per second in 3 seconds. What is the average acceleration of the ride? Well, let's get our initial speed. It's not 0 this time, it's 4. So it's coming over the ride at 4 meters per second, and the final speed is 22 meters per second. A time there again is also 3 seconds. So our average acceleration, we'll set it up the same way we did this. Final speed, subtract initial speed, divide by time. Final speed, okay. What did we say the final speed was? That's 22. 22 meters per second minus initial, and we said that wasn't 0, now it's 4. All of that divided by the time, which is 3 seconds. Putting the numbers in, 22 minus 4, we can say that is 18 meters per second divided by 3 seconds equals 3 goes into 18 6 times, right? So we have 3, 6, 12, 15, 18. 6 meters per second squared. That would be the roller coaster. All right, let's see if we understand. Assess your understanding. Define the rate at which velocity changes is called acceleration. And we want to infer a softball has a what? Positive acceleration when it is thrown, or negative? Correct. It is positive. A softball has a positive or negative acceleration when it is caught. They call that a negative. Explain. A girl skating around a perimeter of a circular ice rink at a constant speed of 2 meters per second is the girl accelerating. And explain. Yes, she is accelerating because we talked about acceleration. Yes, the girl is accelerating because acceleration has to do with direction also. And she is accelerating, the girl is accelerating because she is changing direction. And now I get it. Now I know that in science, acceleration refers to the increasing speed decreasing speed and the last one is changing direction. There you go. If you have any questions on acceleration, be sure to ask your teacher.